वाली है, क्योंकि आज हम पढ़ने जा रहे हैं सबसे पहले रिजल्टेंट फोर्स, उसके बाद पढ़ेंगे हम कंपोजिशन ऑफ फोर्स, उसके बाद रेजोल्यूशन ऑफ फोर्स, एंड उसके बाद बहुत ही ज्यादा इंपॉर्टेंट टॉपिक माय डियर फ्रेंड्स, लॉज ऑफ फोर्सेस और मेथड्स ऑफ कंपोजिशन ऑफ फोर्सेस माय डियर फ्रेंड्स, triangle law of force, parallelogram law of forces, my dear friends. So let us start with the resultant force. So आपको क्लास में बने रहना है, and I promise you all, you will be not having any doubt related to these concepts, my dear friends. Okay, so let us start today class. That's very important, my dear friends. Resultant force. Resultant force. And what is this force? That's very important, my dear friends. So we are going to do what is the resultant force. Okay. Resultant force होता क्या, my dear friends? Suppose हमें दो या दो से ज्यादा फोर्सेस गिवन है और वो फोर्स किसी पॉइंट पे, वो किसी बॉडी के किसी पॉइंट पे एक्ट कर रहे हैं. सो देन व्हाट वी विल डू, वो जो दो या दो से ज्यादा फोर्स हैं जो किसी बॉडी के किसी पॉइंट पे लग रहे हैं, उनका जो भी इफेक्ट होगा उस बॉडी के ऊपर, अगर हमें ऐसा ही कोई सिंगल फोर्स मिल जाए जिसका इफेक्ट भी वो सेम ही रहेगा उस बॉडी पे जो उन दो या दो से ज्यादा फोर्स का इफेक्ट होता है, तो उस फोर्स को हम नाम देते हैं रिजल्टेंट फोर्स, माय डियर फ्रेंड्स. ओके, सो रिजल्टेंट फोर्स इज ए सिंगल फोर्स, माय डियर फ्रेंड्स, ए सिंगल फोर्स whose effect, single force whose effect is the same. 1 minute. Whose effect on a body? Whose effect on a body is same as that of two or more forces acting simultaneously on that body on a point on that body, my dear friends. Let me take simultaneously on a point on that body, my dear friends. On that body, on the same body, my dear friends, you can write. Very important. So that's very important. On that body. That's not a problem. That's not okay. So this is a resultant. So let me take one example. Okay, then you will get better picture about this, my dear friends. So now I am taking. Let us suppose this is a rigid body, my dear friends. Let me take it. Let us suppose this is a rigid body. Okay, be careful. So now what I am taking. Let us suppose there is a force. There is a point. First, we will take a point on the body, and let me take that point over there, and let it is represented by O point, my dear friends. Now, let me take two forces, my dear, acting on this body, and one force on this point, my dear friends. Okay, so let me take this one is two force I am taking right now. Let me take this as P1 and this as P2. Okay, be careful. You can take F1 and F2. That's very important, my dear friends. Any representation you can take. Just you need to understand about concept. Okay, my dear friends. So, and this is what? This is a body, my dear friend, rigid body. Let us go with this as a rigid body. Okay. So now what we are given with F1 and F2, two forces or more than two forces, or a system of two or more than two forces acting simultaneously on a point on a rigid body, my dear friends. So अब हम क्या करेंगे, my dear friends? And let us take an angle between these two is theta, my dear friends. Okay, between these two given forces, F1 and F2 are given forces, my dear friends. Be careful. Given forces. F1 and given forces here, F1 and F2, be careful, very important. Theta is also given, my dear friends, given angle. And this is angle between, included angle between F1 and F2, my dear friends. Okay, be careful. And what is your O point on body, that is also given. Body is also given. Be careful. So now, if now I'm going to replace this system of forces F1 and F2 with a single force, my dear friends, with a single force. Okay. So now replacement means this is equivalent to something, and we will show only single force in that system, my dear friends. So same body on same point. Be careful, my dear friends. That's very important. Okay, be careful. So now I am taking same body over there. Okay, be careful. So same body is there, my dear friends. Be careful. Now let me take one single force over there. Let me take different color. So that. Okay, and let me take this one. Okay. So there I am taking in this force acting at point of, my dear friends. Let me take point also. That's very important. On this same point, my dear friends, and let us know this force is what? This force is R. So what is R, my dear friends, here? R is resultant. Let R be resultant. R be resultant. Okay, of F1 and F2. F1 and F3. Okay, be careful. F1 and F2. Very important, my dear friends. Here. So this is a resultant, my dear friends. And let us take some angle. You can take with line of action of F2. Okay. And this is what, my dear friends, line of action of F2. You can take like that, my dear friends. Okay, let me take 1 minute. So line of action of force, this force, my dear friends, F2. So be careful. So some angle you can take there, not a problem. Okay. So let me take that angle. With line of action of this. Be careful. Let me take this angle as alpha. Okay. As alpha, my dear friends, be careful. What is alpha here? Alpha is the inclination of resultant R with the line of action of F2, my dear friends. This is what this dashed line is, line of action of F2. Line of action of force F2, my dear friends. Be careful, force F2. Something like that, my dear friends. So this is all about resultant force. Now let us move to next topic. So what is the resultant force? This is, my dear friends, R here, resultant force of F1 and F2 something. So let us move to next. Now composition of forces, my dear friends. Very important topic now. Composition of forces. Composition of forces. Composition of forces. And very important, my dear friends, these forces F1 and F2 are coplanar and concurrent. This is very important, my dear friends. Today class will be all about coplanar and concurrent forces. Very important, my dear friends. I am writing here. Today whole class will be about what forces? Coplanar and concurrent, my dear friends. Be careful. Coplanar and concurrent forces. Forces, my dear friends. System of forces you can take, not a problem. So that's very important. Today whole class. Note down it. I have already dictated what is coplanar and concurrent forces of system. System of forces, my dear friend. Now composition of forces. Okay. So composition of forces का simple सा फंडा, my dear friends. जब हम दो या दो से ज्यादा फोर्स लेते हैं, उन दो या दो से ज्यादा फोर्स का हम एक सिंगल फोर्स निकालते हैं जिसको हम रिजल्टेंट फोर्स बोलते हैं. उसी को हम क्या बोलते हैं? कंपोजिशन ऑफ फोर्सेस, माय डियर फ्रेंड्स. So what is that? This is the process of determining a single or resultant force of a given system of two or more force is acting on a body, my dear friends. This is composition. Okay. Process of, it is the process of determining or finding, my dear friends, determining a single force. A single force means that is resultant force, my dear friends. Resultant force of the given two or more than two forces, my dear friends. Two or more than two forces, my dear friends. Two or more than two forces acting on a body. Acting on a body, my dear friends. So this is the composition of force, my dear friends. Now, next, resolution of forces, my dear friends. So this all about large composition force process of this, my dear friends. So we are finding a resultant of given two or more forces. Okay. Now, next, let me take resolution, my dear friends. Resolution of forces. So, 1 minute, just one resolution of a force, my dear friends. Note this composition of forces or resolution of a resultant force, my dear friends, or a force, my dear friends. You can say resolution of a resultant force or a single force, my dear friends. Or you can take here only force also. That's not a problem. Or a force, my dear friends. Be careful. So, so what is resolution? Very simple, my dear friends. हमने पहले क्या पढ़ा, दो या दो से ज्यादा जब फोर्स हमें गिवन हो किसी बॉडी पे वो लग रही हैं तो हम उनका क्या निकालते हैं, रिजल्टेंट। उसको हम क्या बोलते हैं, कंपोजिशन ऑफ फोर्सेस, माय डियर फ्रेंड्स। बट इसके रिवर्स पहले हमने रिप्लेस किया, टू या टू से ज्यादा फोर्सेस जो हमें गिवन थे उनको हमने रिप्लेस किया विद ए सिंगल फोर्स, माय डियर फ्रेंड, दैट इज रिजल्टेंट फोर्स। बट हियर व्हाट वी आर गोइंग टू डू, हियर we will be given with the resultant force, my dear friend. Only single force will be given. So we will resolve that single force, my dear friends, in two components, my dear friends, in two components. And those two components may be orthogonal components or non-orthogonal components. What does it mean, orthogonal and non-orthogonal components? You will get a very clear picture about. Just wait for 2 minutes, my dear friends. So now, process of, so what is the resolution? Process of splitting. It is a process of splitting a single or resultant force, my dear friends, or a force, you can say, resultant force of a single force, my dear friends, into single given, very important in a splitting a given resultant, my dear friends, or given single force, my dear friends, into two components, my dear friends, into two components, my dear friends, in two directions. Or only you can say in two given directions, my dear friends. This is also very important, my dear friends. What I am going to write here, just try to understand, my dear friends. So let me take this first 1 minute. So into two given, my dear friends, into two given directions. Very important, my dear friends. So let us try to understand with an example, my dear friends. So orthogonal components and non-orthogonal components we will take, my dear friends. So let me take one line over there, my dear friends. Okay, be careful. So what we are taking right now, this color and another color I am taking this. Okay, now. So orthogonal components, my dear friends, first. Orthogonal components. Splitting a resultant force into orthogonal components, very important. And then this side, non-orthogonal components. Non-orthogonal components, my dear friends. That's very important. So be careful. So total components, non-orthogonal components, my dear friends. Okay. So let me take now. First, orthogonal components. So now I am taking just one minute, my dear friends. I am taking first. And let me take this as O point, my dear friend. This is X axis, this is Y, my dear friends. And let us suppose we are given with the resultant force, my dear friends, acting at point O, my dear friends. So now I am taking the resultant force acting over there, my dear friends. Just 1 minute, what happens? Okay, this one. So what we are given with the resultant force are, my dear friends. Be careful. Acting at point O, my dear friends. Somewhere on a body, my dear friends. Somewhere on a body. Okay, you can take here a body like that. This is what body. A rigid body, my dear friends. Okay, rigid body. Or a particle, you can take also, my dear friends, a particle. You can also take here a particle, my dear friends. Body or a particle. Both are very important, my dear friends. This concept may be used in fluid mechanics, fluid particle, gas particle, my dear friends, or in solid, rigid body, my dear friends. Be careful. So, orthogonal components of this force means, what does it mean? We have to draw a perpendicular, my dear friends. What we need to do? We need to draw a perpendicular over there, my dear friends. Okay. Let me draw that one perpendicular over there. Be careful. Something like that, my dear friends. Let me take different colors so you will get better picture. Then be careful. Like that, okay? And this is orthogonal component, my dear friends. You can take this also, that's not a problem. Be very important, my dear friends. So one component you can take over there. So there, my dear friends. Another component. Let me take different color. And that is another component, my dear friends. So here, let us suppose this is Px and this is Py, my dear friends. So what is Px and Py here, my dear friends? This is 90 degree, my dear friends. Px and Py included angle 90 here. Okay, be careful. So Px and Py are what, my dear friends, here? Orthogonal components. Be careful. These are orthogonal components of this resultant force, my dear friends. Let us suppose this angle is what? Theta, my dear friends, or you can take alpha. That's not a problem. Let us suppose this is theta, my dear friends. Okay. So these are orthogonal components. So now R has been resolved into two components, my dear friends. So either you will show this resultant force or you will show there. Don't take this, my dear friends, then only show these components over there on that body. By taking like that. By taking body like that. And just show these two components, my dear friends. On same point on that body. Just show these two components. One component over there and another component over there, my dear friends. Be careful. These are making 90 daily, right? Where? At O point, my dear friends. This. So this is Px, my dear friends. That's okay, Px. And this is Py, my dear friends. So this is equivalent to this. So then you don't need to show this, my dear friends. Be careful. So, so now what you need to do, my dear friends? Very important, I'm telling you. Now just I am doing, I am erasing this component, my dear friends, over there. Be careful. And this component. what I'm going to do right now. So let me take there something like that, my dear friends. Be careful. The line. This is OX. Be careful. In this angle, you can take as theta. So what you are given with, what we are given with this, my dear friends. So this problem is equivalent to this problem. Be careful. So this problem is equivalent to. So this is the resolution of force, my dear friends. This resultant force R this resultant force R now has been resolved into Px and Py, my dear friends. So how will you get then those Px and Py value, my dear friends? I have already shown you right angle triangle over there. So this component along OX direction will be equal to what? R cos theta, my dear friends. So then, so what will be value of Px, my dear friends? This value will be equal to R cos theta. And what will be Py? R sin theta, my dear friends. And these are the resolved components of a single force or resultant force, my dear friends. So now let us move to next known orthogonal components. That's very important, my dear friends. Now, known orthogonal components. Okay. So let me take there also a body, something like that. Be careful. Let me take a resultant over there, something like that. R acting at point O, my dear friends. And this is a body, rigid body, or a particle you can take, my dear friends. So in known orthogonal components, what we will be given with the two directions we will be given. We will resolve this resultant in those two directions. Very important, my dear friends. Now let us suppose this R is making some angle. Okay. With this direction. So let me take a different color. Okay. So then no confusion at all. This X direction you can take not a problem. And this angle is theta, my dear friend. For alpha, you can take not a problem. Here I think. And this angle is what? Theta, my dear friend. This angle is theta. Okay. So now this is given. But what we need to do, say this is given, but now what we need to do? We need to resolve in known orthogonal components, my dear friends. So what will you do then? Very simple, my dear friends. You will take this body, same, my dear friends. So now you will take 0 point. Then don't need to solve now. Result need to be careful, my dear friends. Now we need to solve only two components of this first. Be careful, okay? And so one component, two directions given, my dear friends. So let us suppose one direction is something like that. One direction is given something like that, and another direction is given something like that, my dear friends. Be careful. And let us suppose this angle is given. This angle is also given to you, my dear friends. This angle is also given alpha. Very important, my dear friends. Two directions are given. So what we will do? We will resolve this resultant force now in two directions, this one and this one direction, my dear friends. Be careful. And both directions having included angle as alpha. Be careful. So now this resultant will be somewhere in between, my dear friends. Be careful. So this resultant will be somewhere in between, my dear friends. Be careful. So let me show this resultant now taking its color. Okay. This one. So let me take it now, add a dotted line. So let me put 14 line. Okay. This is what this is given R, my dear friends. So now this R, okay, making and let us take one direction along OX, my dear friends. Okay, now I am taking this is in OX direction, my dear friends. Okay, be careful. So let me erase this first. This 1 minute, just 1 minute, my dear friends. Okay, so this course is given to us. Let me take it into. Okay, and let me take this direction. Let's also bear my dear friends. Be careful. Okay, so now I am taking a line. Common line and let me this color. Let me take this. Let me take this. Okay, so what I'm going to do right now is so along OX directions, my dear friends. One direction is along OX. Okay, be careful. So that's very important, my dear friends. So these are two components now here. Okay, so that one component is PX along OX direction, my dear friends. That's very important. This is PX component, and this component is what, my dear friends? We don't know. It is not orthogonal component to P by something like that. Be careful. So let us take it as P2. This as P1, my dear friends, and this as P2. So these P1 and P2 here now by right, my no orthogonal components. So here what are these two components, my dear? P1 and P2 are non-orthogonal components. Be careful. So that is the resolution of a single resultant force or resultant force along OX direction. Another is this direction, my dear friends. These two resolved non-orthogonal components of resultant are P1 and P2, my dear friends. Be careful. There is a method now how to find out this P1 and P2 value, my dear friends. Then we can find out R will be given to you, my dear friends. Be careful. This angle will also be given to you, my dear friends. This angle, theta, let us call it. R making with OX. Theta will be given. Be careful. What will be given here first? Then you can only find out value of P1 and P2. Otherwise, not. Otherwise, it is not possible, my dear friends. So theta will be given to you. Given data, theta, and R value, my dear friends. And also alpha, my dear friends. So these three value will be given to you, my dear friends, here in this problem. Then only you will be able to find out what value of P1 and P2. Non-orthogonal components of a resultant force are, my dear friends. So now let us move to next, my dear friends. Very important topic, last topic of today class, my dear friends. So just be in class. Now we can say large of forces, my dear friends. Large of forces, or you can say method of composition of method of composition of forces. Be careful, my dear friends. And first, what is first law of forces, my dear friends? Parallelogram law of force, my dear friends. What is first? Parallelogram law of force. Parallelogram law of forces, my dear friends. Parallelogram law of forces. This states that this states that if the if the two forces if the two given forces, my dear friends, this states that if the two given forces acting simultaneously acting simultaneously on a body acting simultaneously on a body, two given participants on a body are represented are represented or we can say taken on a body are taken along the two adjacent sides along the two adjacent sides of a parallelogram of a parallelogram, then the resultant of these two forces, these two coplanar and concurrent forces, my dear friends, be careful. These two coplanar and concurrent forces will be the will be the result will be the diagonal of parallelogram diagonal of parallelogram passing passing through passing through the intersection point passing through the intersection point of these two forces of these two given forces, my dear friends. So this is nothing but this is the statement of parallelogram law of forces. कहता क्या है, हमारे पास कोई समांतर चतुर्भुज है, उसकी दो भुजाओं तो आजू बाजू की जो भुजाएं हैं उनके के ऊपर हम दो फोर्स लेते हैं, गिवन फोर्स दो फोर्स हम लेते हैं उनकी पैरेललोग्राम समांतर चतुर्भुज की भुजाओं पे, तो हो गया क्या उस केस में, जो समांतर चतुर्भुज का पैरेललोग्राम लाकर जो विकर्ण बनेगा, विकर्ण डायगोनल बनेगा, वो किसकी वैल्यू देगा, वो रिजल्टेंट उन दो फोर्सेस जिनको हमने उसकी आजू बाजू साइड्स हैं जो उनके लिए उनके रिजल्टेंट की वैल्यू कौन देगा, डायगोनल देगा माय डियर फ्रेंड्स. तो बी केयरफुल एंड डायरेक्शन आल्सो माय डियर फ्रेंड्स. सो देन द डायगोनल of that parallelogram passing through the, be careful, so then diagonal, that will be the diagonal, and this diagonal, my dear friends, and this diagonal will give the value of resultant and direction value. This diagonal will be, and this diagonal will give the value and direction, my dear friends. Be careful of that resultant, my dear friends. Sorry, 1 minute. Let me check. First, something we need to write it like that. So be careful. Will be, so then this diagonal will give the magnitude and direction of resultant. Very important, my dear friends. Be careful. So now, अब हम दो अप्रोच पढ़ते जा रहे हैं माय डियर फ्रेंड्स, मेथड्स ऑफ कंपोनेंट्स ऑफ फोर्सेस, कंपोजिशन फोर्सेस, ग्राफिकल मेथड, एनालिटिकल मेथड. फर्स्ट एनालिटिकल मेथड्स हम पढ़ते हैं और वहां से हम रिजल्टेंट निकालने की कोशिश करेंगे. हाउ वी कैन वी डिटरमाइन द वैल्यू ऑफ रिजल्टेंट बाय पैरेललोग्राम लॉ ऑफ फोर्सेस बाय ऑप्टिंग एनालिटिकल मेथड. Okay, my dear friends, and I will also tell you about graphical method, how you can find out resultant by using this concept by graphical method. Okay, so now let us suppose we take two forces, my dear friends. Okay, on two sides of a parallelogram, very important. So let me take it first. Very important parallelogram here over there. So that will be very important, my dear friends. So this is a parallelogram, my dear friends. So be careful. So now I take the force. So let us suppose this is a one force over you can take there my difference, and this is another. This is your point. Two forces acting on point A O on a body my difference. You can take a body over there like that. Okay, this is body. Okay, be careful. For a particle, you can also take my difference. So let us suppose this force is F1 my difference. So let me take it as clear F1 and this is F2. Along, you can take this side OA side my dear friends, this side OB side my dear friends of parallelogram. So and the angle between these two will also be given to you my dear friends. Let us put this is theta. Okay, theta my dear friends. So now what we are going to do my dear friends here, we are now taking diagonal of this parallelogram ABC, OABC. Okay, what is OABC? OABC is my dear friends. This is given parallelogram. Given parallelogram, my dear friends. Okay, be careful. So now I am going to do one very important my dear friends. Okay. So now what I am going to do, I am going to OA to be extended and we will draw perpendicular from C after extension of OA. Okay, towards right side. So we are going to do a perpendicular. Okay, going to draw a perpendicular. So let me draw that. Okay, be careful. Over there, my difference. Let me take this straight line. Now let us extend OA. Okay, then we need to draw a perpendicular from C. One OA as 3D, my difference. Okay. So now I'm taking extending this line. Okay, something like that. Be careful, my difference. So let us take this point, big point my difference. And this is perpendicular. Be careful, my difference. So if this angle is theta, my difference, OB is parallel to AC, my difference, and AC is equal to OB in a parallelogram. Be careful. So this angle would also be how much my difference when theta my difference. Then this angle is also what? Theta. Be careful. So what is the value of CD now? Analytical method now we are going to use my difference. This is analytical method. Okay, be careful. So by analytical method, what is the value of CD, my dear friends? First, you need to take my dear friends, this diagonal also. So let me take that first. Let me take that by some different color. Value we have taken this color. Okay. Let me present this diagonal. Okay. So be careful. This is a resultant, my dear friends. The resultant are making an angle alpha with the F1. Okay, be careful, my dear friends. We we have taken it like that. Okay. So अब हम निकालते हैं in right angle triangle ACD, my dear friends. So what is value of CD by using trigonometry? So value of CD will be equal to R in this triangle, my dear friends. Sorry, we need to take in right angle triangle here right now. Right angle triangle, right angle triangle OCD. OCD. So what is the value of CD? If you will find out, base is this one, so this is perpendicular by hypotenuse. Perpendicular by hypotenuse is nothing sine this angle alpha, sine alpha, that is just 1 minute by difference. That is sine alpha. So just 1 minute. This is our here we go perpendicular. Now we are taking this. That's okay. This angle will also come into picture. So we are going to take right now this angle. Okay. So that's very important value first. Just 1 minute. No, there is no mistake. Okay. We have taken it properly. That's not a problem. Okay, my dear friends. So this is what? This is F2 force, okay? That's okay. This is F2, okay? So now CD is equal to, in this triangle, so it is different, in this triangle it is different. So, but now we are taking this, my dear friends, be careful. Yeah, we will take right angle triangle. We will take in right angle triangle ACD, my dear friends. Right angle triangle ACD. Be careful. So CD will be equal to F. F2, this is F2, my dear friends. F2 sine theta, my dear friends. And then AD will be equal to my dear F2 cos theta. F2 cos theta, be careful. Have to divide it cos theta. Okay, be careful. And what is value of OA? F1. So what is OD, my dear friends? Value of OD will be equal to OA plus AD. OA plus AD. So that is nothing. OA is how much? F1. And AD is F2 cos theta, my dear friends. Okay. This one. So now what is the value for resultant arc, my dear friend, in right angle triangle OCD? Very important, my dear friends. So what is the value of resultant arc by Pythagoras theorem, my dear friends? So R is the hypotenuse in right angle triangle OCD. I am going to apply Pythagoras theorem, my dear friends. So square of hypotenuse is equal to the square of perpendicular plus square of the base, my dear friends. In OCD right angle triangle, so R will be equal to then R square will be equal to what? R square will be equal to CD square, OD square, my dear friends. OD square plus CD square. Okay. So now put the value of OD, my dear friends. So we have taken it here. We have F1 plus F2 cos theta, its whole square. And then what is the value of CD, my dear friends? F2 sin theta. Okay. Plus F2 sin theta, its whole square, my dear friends. Be careful. Then A plus B whole square. So then you will do that, my dear friends. So what will you get then? R square is equal to A square plus B square. Okay. F1 square plus F2 square cos square theta plus 2AB, my dear friends. This is A, this is B value. B is equal to F2 cos theta. Be careful. So 2 F1 F2 cos theta is equal to, my dear friends. Oh, plus. Not equal to, this is plus, my dear friends. Let me take it plus F2 squares and then sin square theta, my dear friends. Sin square theta. Okay. So then what you can do in this, my dear friends, in this F2 cos square theta plus F2 sin square theta. So what is mistake here? So just 1 minute, my dear friends. This is F1 plus F2. 2 F1 F2 F1 plus F2 F1 square like this. Okay. Yes. F2 it's okay. F2 square you will take common. So then what you will get from this two term F2 square cos square theta plus F2 square sin square theta. F2 square will be common. So then cos square theta plus sin square theta into the bracket cos square theta plus sin square theta. That is 1 by difference. So you will get then R here. Okay. So what you are going to get R value here. So let me take to next slide. Now very important, my difference. So you got R square is equal to F1 square plus F2 square take common cos square theta plus sin square theta plus 2 F1 F2 cos theta. Cos theta, let me take it first. Cos theta, my difference. So what is this value equal to? 1, my difference. Sin square theta plus cos theta is equal to 1. So R value will be equal to then R square F1 plus F2 square plus 2 F1 F2 cos theta. So now what is R value, my dear friends? take this side square root of square root of both sides, my dear friends. So f1 square plus f2 square plus 2 f1 f2 cos theta. So this is the value of what, my dear friend? Resultant. This one. Okay, be careful. So now let us check what angle we have taken here, alpha. Now we are going to find out an inclination alpha for resultant with the uh, f1. Okay, my dear friends. So tan alpha will be equal to what? In this right angle triangle, OCD. OCD. So tan alpha will be equal to perpendicular by base, my dear friend. What is perpendicular? CD by base OD, my dear friend. So CD by OD, my dear friend. So tan alpha, angle of inclination of resultant with the f1 vector, my dear friends. So let me take it to next. Okay. So what is the tan alpha is equal to OD. That is f1 sin theta upon AD. And that is what? F1 plus F2 cos theta. So here you can find out value of alpha, my dear friends. Tan inverse F1 sin theta upon F1 plus F2 cos theta. This. So what is this, my dear friends? Alpha. Inclination of angle made by resultant with F1 vector. Inclination of resultant are, my dear friends, with F1, my dear friends. So this is all about this, my dear friends. So now very important question, case first, my dear friends. Now case first, when this R will be maximum. So if I use mathematics, my dear friends, so I'm going to tell you, okay. So जिनको मैथ आता है, गणित आता है अच्छे से, उनके लिए तो प्रॉब्लम नहीं है, लेकिन मैं कोशिश करूंगा अच्छे से समझाने की। तो अब हम क्या करते हैं, हम इस इक्वेशन को ही ले लेते हैं r square plus this. And now I am taking f some different function. Okay, I am taking y. Okay, let me take some different function y is equal to r square, my dear friends. I am taking y, r square is equal to y, my dear friends. So be careful. So y is equal to then f1 square plus f2 square plus 2f1 f2 cos theta. And be careful, my dear friends. F1 and f2 are constant here. F1 and f2 are constant. So we will take f1 and f2. These are constant value. Not changing with theta. And what is theta here? Variable, my dear friends. Theta is a variable. Value of f1 and f2 are constant. The value of this f1 and f2 are fixed, my dear friends. If this is 100, this is 200. So they won't change. This will be 100, this will remain 200. Be careful. But theta value is a variable. Its value can vary. According to that, this value y or r square will vary. R will vary, my dear friends. Be careful. So now I'm going to differentiate this function y with respect to. I'm going to differentiate this r with respect to theta. Theta is variable here. Be careful. So dy by d theta. F1 and F2 are constant. Constant differentiation of F1 with respect to theta is 0. F1 is a constant, my dear friends. Differentiation of this is 0. Constant. This is a constant value. Plus differentiation of this also 0. Constant. But this is here what? Constant 2. And F1 and F2 also constant. So this constant will take a common out. Be careful. Then cos theta is a variable. Cos theta is changing with respect to theta. Be careful, my dear friends. So there you will get then 2f1, f2. And differentiation of cos theta with respect to theta, my dear friends, minus sin theta. So you will put there then minus sin theta. So what you are going to, what you will get? Minus 2f1 f2 sin theta dy by dx or dy by d theta, this value. Now what we will take two conditions, my dear friends. Maximum when resultant r will be maximum, and another case when r will be minimum. So r will be maximum if d square y by d theta square, if d square y by d theta square is less than 0, my dear friends. and R will be minimum if d square y by d theta square is greater than 0, my dear friends. Be careful. Second differentiation of y with respect to theta. So what will be d square y by d theta square from here, my dear friends? So now d square y by d theta square will be equal to what? Minus as it is. 2 F1, F2 is constant, product of constant always. So 2 F1, F2 as it is, my dear friends. And what is then sin theta? Differentiation of sin theta, my dear friends. Cos theta. Be careful. Differentiation of sin theta. D sin theta by d theta, my dear friends. Differentiation of sin theta is what? Cos theta, my dear friends. Be careful. So now this, my dear friends. So here what you are going to put first, you need to find out here theta value, my dear friends. So what you need to do, put dy by dt theta is equal to 0. You need to put this value is equal to 0, my dear friends. So here you will get what value of theta then. So this implies sin theta is 0 here. Sin theta is 0. So when theta is 0, then sin theta is also 0. Sin 0 is always 0. When theta is 0, my dear friends. And when theta is 180, sin 180 is also 0, my dear friends. So theta is 0 or theta is 180, my dear friends. So then sin theta is always 0. Be careful. So sin theta is 0 between when sin theta. 1 minute. Let me check this. Very important, my dear. So if theta is 0, so then what? Sin 0 is also 0. Be careful. If theta is 180, then sin 180 is also 0, my dear friends. Be careful. So now I'm going to put theta value is 0 in this square y by d theta square. We need to check it after putting theta value. So if I am going to put theta over there, my dear friends, 180, so 0. I am going to put theta equal to 0 in this equation, my dear friends. So d square y by d theta square. Just 1 minute. At value of theta is equal to 0. Put here in this equation. So what you will get? Minus. This is minus. This is some values. Positive value, my dear. Absolute F2 value will be positive. Be careful. 100 into 200, you can take not a problem. Example. Cos 0. Cos 0. Cos 0 is what, my dear friends? 1. So this is minus negative value you will get over there, my dear friends. So be careful, negative value you will get. So what does it mean? Negative value less than 0. Negative value means less than 0, my dear friends. So b square by theta square is less than 0. At what value of theta? 0, my dear friends. So be careful. So at value of theta. So R will be what? Maximum, my dear friends. And what will be value of R then? Put theta is equal to 0, my dear friends, in this equation. So this will be the maximum value of R, my dear friends. Be careful. And how much it is that R maximum? We will get maximum, my dear friends. How much? Put theta 0. Cos theta will be, cos 0 will be 1, my dear friends. Be careful. Cos 0 is 1, my dear friends. If you put over there, so you will get F1 square plus F2 square plus 2F1 F2 into 1. So what you will get? A square plus B square plus 2AB. That is nothing a plus b whole square, my dear friends. So f1 plus f2 whole square and then square root, my dear friends. f1 plus f2, its whole square, then its square root, my dear friends. So you will get here what? Square root. This power will cancel out. f1 plus f2, my dear friends. So our maximum value is what? f1 plus f2. If angle between, let me show you that slide. If this value is theta, with angle between f1 and f2 is 0 degree, then R will be maximum always, my dear friends. Be careful. So let me take minimum to minimum. Now put theta is equal to 180 in this equation, my dear friends. There, in this, where is that value? In this value, my dear friend. Put now theta is equal to 180. This square y by 3 theta square is equal to, put it now. So cos theta. Now put theta is equal to 180 and cos pi, my dear friends, in or cos 180 is minus 1. Be careful, my dear friends. Minus 1. So minus 2f1, f2 into minus 1. So minus minus plus value. positive value which is greater than 0, my dear friends. We will get non-zero value here. Non-zero you will get because F1 and F2 neither force are 0 here. Be careful. Both are non-zero force. Be careful. Then we will get positive value greater than 0, my dear friends. So then then R will be minimum at theta is equal to 0, my dear. 180, my dear friends. So R will be minimum. Be careful. Put that value here in that equation to find out minimum value. So what will be minimum value, my dear friends? This side you can take R minimum. So when you put 180 cos 180, my dear friends, so you will get here what formula you will get? Square root of F1 square plus F2 square minus 2F1 F2 to F1 F2. You will get this because cos theta is minus 1, my dear friends. Put there. So minus 2 F1 F2 A minus B. So F1 minus F2. F1 minus F2 its whole square, my dear friends, and then square root. So you will get the square root can get cancelled out. So what will you get then? F1 minus F2, my dear friends. So this is R minimum, my dear friends. R minimum. So what is R minimum? F1 minus F2, my dear friends. When? Let me show you that. When this angle theta will become, my dear friends, 180. When? So then it will between F1 and F2, then R will be minimum. So be careful. So it is something like that. Let me show you. So in this case, maximum case, my dear friends. So R maximum means when R maximum, F1 is in same direction and F2 is also in same direction, my dear friends. Then this here theta is equal to 0. Then only R will be maximum. And that value will be F1 plus F2. Be careful. And what R will be minimum, my dear friends. Let me take over there. That's not a problem. When F1 is something like that and F2 is something like that. An angle between these two is 180, my dear friends. Then its minimum value will be equal to F1 minus F2. It's you can take modulus. But difference you need to you have to take then F1 minus F2. We are taking here F1 is greater than F2. F1 value is greater than F2. We are taking it. But here we have taken it like that. So take it F1, my dear friends, and this F2. We are taking F1 is greater than F2. And both are acting from there at this point, my dear friends. F1 and F2. F1 magnitude is more than if F2, then you need to take R minimum F1 minus F2. If F2 is greater than F1, then you need to take F2 minus F1. Be careful. Here not a problem in maximum. That is F1 plus F2. So this was all about, my dear, parallelogram law of forces, analytical method, which is used to find out resultant of two given forces. Be careful, coplanar and concurrent forces, my dear. We are today class is all about coplanar concurrent forces, two or more than two forces. Over the resultant, we are going to resolve into two coplanar and non-concurrent forces, my dear friends. So now let us start last of today. Triangle law of forces, my dear friends. Last. Triangle law of forces. Triangle law of forces. Okay, before that, I am graphical method. Let me tell you graphical method first. So let me take graphical method first. Okay. So graphical method. Okay. अब हम थोड़ा हिंदी में पढ़ लेते हैं. ग्राफिकल मेथड में हम क्या करेंगे, हमें एक स्केल माननी होती है, माय डियर फ्रेंड्स. लेट अस टेक 2 न्यूटन इज इक्वल टू, लेट अस सपोज 2 न्यूटन इज इक्वल टू 1 सेंटीमीटर and we are given with what F1 force, my dear friends, is given 10 Newton, and let us suppose F2 is given 5 Newton, my dear friends. Okay, with example I am now going to dictate. आपको समझाने जा रहा हूँ example लेके. So angle will also be given to you, my dear friends. You get theta is for 45 degree. Okay. So what will you do then? First you will draw both forces acting at on a common point. Be careful. So first you will take 10 Newton is equal to how much centimeter? So you need to take 10 Newton is equal to how much you need to then in centimeter. This is assumed scale. Be careful. Assumed scale. So 10 Newton will be equal to 5 centimeter then, my dear friends. Be careful. Okay, draw. You need to draw this on graph, my dear friends. Okay. So you need to draw this first. Okay. And graphical method is so by vector, my dear friends. so vector also. Okay, be careful. So now you need to draw how much, my dear friends? You need to draw how much? 5 centimeter. And this is nothing, this is F1, my dear friends. Let us take this whole point. Okay, be careful, my dear friends. Then draw S2, my dear friends. How much? 5 Newton then. This is F1, this is F2, my dear friends. Okay. This will be equal to how much then? 1 centimeter is equal to 2 Newtons. So 2.5 centimeter, my dear friends. 2.5 centimeter. Okay, you draw then. So what is how much angle is given? 45 degree. So you need to take then how much angle, my dear friends, here. So let me take just 1 minute. So I'm taking another force. Okay, but how much you need to draw then? That's very important, my dear friends. Okay. 2.5 centimeter at an angle of 45 degree. Okay. So you will take 2.5 centimeter. Okay. Something like that, my dear friends. 2.5 centimeter. But what angle? 45 degree. So you will draw with this line. Okay. Take this OA, take this OB vector. Okay. F2 along OB and F1 along OA. So first you draw this 5 centimeter. Then at 45 degree, draw this 2.5 centimeter, my dear friends. 2.5 centimeter. Okay. So then what you need to do, then you need to complete a parallelogram. Now complete a parallelogram. So what you will do? Parallel to this line, you will draw a line from there, my dear friends. So what will you do then? What will you do then? Parallel to this OB, you will draw a line here. Okay. AC, you can take note of problem. Like that. Okay, be careful. And from this B point parallel to a dry line from B. Okay. Somewhere that line will intersect this already drawn line. Okay. So be careful, my dear friends. Here. So now what do you need to do? Let us put this, you need to take, let us put this is C point. Okay. So now join O with C. So then what you need to do? Join O with C. Join O with C. Let me take it. With that. So what is this resultant, my dear friends? Then what you need to do? Then measure OC. Then you join O with C. Join C with O. Then measure OC, my dear friends, in centimeter. Then convert back it into this scale, my dear friends, in Newton. So you will get value of what? R, my dear friends. So R value you will get here. And it's a direction, my dear friends. You need to measure then this angle, my dear friends. You have to measure this angle. Be careful. You need to find out this also, my dear friends. So then measure this angle, alpha over there. So alpha. You have to measure. Measure it. Measure it. Okay, be careful. So alpha you will get then here. So this all about graphical method, my dear friends. Okay. आगे बढ़ते हैं ट्रायंगल ऑफ फोर्सेस के बारे में पढ़ते हैं लास्ट ट्रायंगल ऑफ फोर्सेस just 1 minute let me put charger first my dear friends okay my dear friends triangle of forces so triangle of forces क्या कहता है my dear friends हम इसमें दो फोर्स लेंगे ट्रायंगल की दो साइड्स के ऊपर हमको रिप्रेजेंट करेंगे ऑर्डर में लेके चलेंगे उन दोनों फोर्स को हम उसके बाद ट्रायंगल की जो थर्ड साइड होगी क्लोजिंग साइड वो आपको रिजल्टेंट की वैल्यू देगी और उसके रिजल्टेंट की डायरेक्शन देगी with respect to any force F1 or F2 by difference. So this law of forces states that if the two forces be careful coplanar and coplanar and concurrent by difference coplanar and concurrent forces. We are studying about this coplanar and concurrent force. Whatever we studied today in today class, this was all about coplanar and concurrent forces. Okay, so this last states that if two forces are taken in order along two sides, of a triangle, of a triangle, then the other, then the third side will be the resultant, will be the resultant of, then third side will be the resultant of these two forces taken along on other two sides. Be careful, my dear friends. And direction also will be given by the third closing side, my dear friends. Be careful. Taken in opposite order. That's very important, my dear friends. Then that sides will be the resultant of these two forces, and resultant will be in the opposite order. Be careful. And that third side will be the resultant, and then the resultant will be in the opposite order. Be careful, my dear friends. Shown by third side in opposite order. What does it mean? Now I'm going to dictate. आपको समझ में आ जाएगा कहीं. So now हम पहले साइड्स ले लेते हैं. एक साइड्स के हम वेक्टर ले लेते हैं OA. If we are taking graphical method or vector, otherwise take it analytical, so it is not a vector. Just what we are taking here right now. Be careful. So this is analytical approach I am taking right now, my dear friends. Analytical method. Okay. Graphical is very already dictated to you, my dear, very easy, my dear friends. So now OA side. OA is what side, my dear friends? Let this process are full. Okay, be careful. Now another side. Let us take another side. So let me take another side. AB, my dear friends. AB. And let us put this in the active force, my dear friends. A to B. Okay, be careful. A to B. Then okay. So then what you need to do, my dear friends, complete this. So we will take this third side. Okay, be careful. That's very important. So let me take this. Okay, different color then. So let me take this color. Okay. So then this. So let me take it. This light red. So what is this, my dear? Resultant R. This is R, and angle is also given, my dear friends. So you can take angle between this F1 and F2. Okay. You can take this angle as a 180 minus theta. Let us first check this angle. First extent, line of action of this force is this. Line of action of F1 is this, my dear friends. Let us suppose F2 is making an angle. Making an angle theta, my dear friends, with line of action of force F1. Okay, it is something like that. So let us put this angle is called alpha. Resultant making with F1. Okay, so this is this. Then you can find out also this angle, my dear friends. So this angle will be equal to how much, my dear friends? So this is Z. So Z will be equal to all sum of all three angles in a triangle is always 180. So 180 minus this will be, my dear friends. So 180 minus alpha, then plus 180 minus theta. So then you will get what value, my dear friends? How much you are going to get with? Is there any? Okay, this will theta minus alpha. So this value will be equal to then that value. This will be equal to theta minus alpha, my dear friends. Now, so now question is, sir, अब आर की वैल्यू निकालेंगे कैसे, अल्फा की वैल्यू कैसे निकालेंगे, निकालना तो हमें क्या है, आर एंड अल्फा। हम पढ़ क्या रहे हैं माय डियर फ्रेंड्स, मेथड ऑफ कंपोजिशन ऑफ फोर्सेस। And what is composition of forces, my dear friend? If two or more than two forces are given, then these two more than two forces can be replaced with a single resultant force, and which is to be determined. So वही करने जा रहे हैं, रिजल्टेंट निकाल रहे हैं और इसका एंगल ऑफ इंक्लिनेशन विद फोर्स F4 निकालने जा रहे हैं. So R और alpha निकालना है. So now why sin law? This is now rectangle. This is a triangle. In a triangle, OAB. Why sin law? Why using sin law? Sin formula, my dear, or sin law, which is applicable to a triangle. So what is this law states that the force, the particular force, the individual force, or respective force, the individual force, suppose F1 will be equal to the directly proportional to, will be directly proportional to the sine of included angle, will be directly the individual force on any side will be directly proportional to the sine of included angle between other two sides. The individual force on a side will be directly proportional to the sine of included angle of forces on other two sides. Okay. So sine of so let me take it there equal to, so then you will get, okay, sine take sine of included angle between forces on individual force on any side. Be careful, my difference in force on any side. Forces shown on other two sides. So forces shown on other two sides of a triangle. Okay. So individual force shown on one side of a triangle, be careful, will be directly proportional to the sine of included angle. Okay, be careful. So now I am taking this force F1, my dear friends. So try to understand now. I am taking F1 force. So now it is what? Proportional to, as per this statement, my dear friends. F1 is directly proportional to sine of included angle between other two forces shown on other two sides. That is what? Sine of Z, my dear friends. So what is that value? Theta minus alpha. Theta minus alpha. Okay, right? Theta minus alpha. Okay, that value is theta minus alpha. So this is first equation, my dear friend. Now F2 will be similarly, F2 will be directly proportional to what? F2 sine of this angle alpha, my dear friends. Be careful, this is another equation. Third one is R, my dear friends. And what is R? Proportional to R will also be proportional to sine of 180 minus theta. This, my dear friends, sine of 180 minus theta. So now let me take here this right now. F1 is directly proportional to sine theta minus alpha. So let me take constant of proportionality K. Sine theta minus alpha. Then F2 will be equal to constant of proportionality will be same, my dear friends. Be careful. Sine of alpha, and then R will be equal to K into sine of 180 minus theta. And sine 180 minus theta is nothing sine theta. So what did you get? This, my dear friends. So now find out value of K from here. So K value will be F1 upon sine theta minus alpha. And here K value will be also equal to F2 into F2 upon sine alpha. What is K value? F2 upon sine alpha. And here what is K value? R upon sin theta. This. So what you will get then? All three are equal. F1 upon sin theta minus alpha. Be careful my difference is equal to F2 upon sin alpha is equal to R resultant upon sin theta. And this is nothing, it is sine law, my dear friends. This is sine law applicable to a triangle. If you want to find out unknown values, you need to use then this for a triangle. Sine. So this is sine, all about sine law. So you can find out there then R value, because what will be given to you, my dear friends? F1 will be given to you, F2 value will be given to you, theta value will be given to you. Only this three will be given to you, then you need to find out R value and alpha value by using sine law. This, my dear friends, so be careful. So this all was all about, my dear, triangle of forces. And graphical method also same picture I already dictated about graphical methods. आपको करना है ग्राफिकल में F1 आपको गिवन होगा, F2 ये थीटा की वैल्यू आपको गिवन होगी, माय डियर फ्रेंड. तो आपको F1 ड्रॉ करना है, स्केल ले लेना है, उसके बाद आपको F2 ड्रॉ करना है, थीटा आपको गिवन होगा. तो इस तरह आपको F1 लेना है, फिर यहाँ से इसको एक्सटेंड करना है हल्का सा थीटा वैल्यू पे जो गिवन है. आपको F2 ड्रॉ करना है सेंटीमीटर में, और फिर उसको B पॉइंट को आप O पॉइंट से ज्वाइन कर देना. R की वैल्यू आप मेजर कर लेना सेंटीमीटर में, तो आप बाद में उसको स्केल जो आपने माना है सेंटीमीटर को न्यूटन में, बाद में न्यूटन में कन्वर्ट कर लेना है, और ऐसे ही आपको ये अल्फा जो एंगल आप मेजर कर लेना है. तो दिस वाज ऑल अबाउट टुडे क्लास. सो नाउ आई एम गोइंग टू स्टॉप टुडे क्लास. ओके. And in last, I want to say thank you to you all, my dear friends, from the depth of my heart. See you soon tomorrow class. Thanks everybody.